Next, we are going to look at how to do this process algebraically rather than using a graph. So, given f of x equals x squared minus 3 and epsilon equals 0.1, algebraically find a delta greater than 0 such that the absolute value of f of x minus 13 is less than epsilon when the absolute value of x minus 4 is less than delta. Okay, so let's start out with a couple things here. We know our function, we know our epsilon value. Now, we do also have the values of c and l here as well. Notice that our definition has absolute value of f of x minus L. So this is L right here. L equals 13. And the definition has the absolute value of x minus c. So this is c right here. C is 4. And we can check that. All right, limit as x approaches c, oops, except we know c is 4, there it is. And our function is x squared minus 3. So if we plug in direct substitution, x equals 4, okay, that would be 4 squared, 16 minus 3 equals 13. And so yes, that is our L value, that's our limit. All right, so we want to find a delta that goes with this epsilon value, but we're not going to use a graph. Okay, we are going to start with this side of the definition, this f of x minus L absolute value less than epsilon. So f of x minus 13 inside those absolute values is less than epsilon. But we happen to know what f of x is, so we could put that in there. X squared minus 3 is f of x. So we have x squared minus 3 minus 13 inside our absolute values. That'd be x squared minus 16 there, is less than epsilon. But we also know what epsilon is. Epsilon is 0.1. So let's put that in too. We could have done it in this previous step. Epsilon is 0.1. And so now we have an absolute value inequality, and we can look at solving for x here. Okay, now recall for absolute value inequalities, maybe it's been a little while, this type of absolute value inequality where the absolute value is less than a certain number. That means we are within this distance along the x-axis. So we're going to have, if we remove the absolute values, a 3-part inequality, like a little inequality sandwich that looks like this. Okay, so taking off the absolute values gives us a positive and negative option here. So negative 0.1 is less than x squared minus 16, and that's less than positive 0.1. Now, let's go ahead and add 16 to all 3 parts. We would get 15.9 less than x squared less than 16.1. Okay. Next, if we want to just focus on x itself, we could take the square root of all 3 pieces. It would maintain that same inequality relationship. I'll bring it up here. So you're going to square root each piece. And square root 15.9, that would be 3.99 less than x in the middle now. And then square root 16.1, that would give us 4.01 there. Okay, so we have now an interval for our x values, but let's think about algebraically, we're focusing in on a c value of 4, and this inequality statement, absolute value of x minus 4 is less than delta. Instead of just looking at x right here, let's look at x minus 4 and see what the range of values for that is going to be. So we can do that by just subtracting 4 from all of these pieces. And we'd get negative 0.01 less than x minus 4 is less than positive 0.01. Notice, if you will, how this statement looks very, very similar to this statement, okay? It's a kind of symmetrical inequality there. We could rewrite this as an absolute value inequality. So it's like going backwards from this step over here to the previous step. Okay, we can turn it back into an absolute value. Okay, maybe I'll keep those highlighted for us. Okay, so to absolute value, that would mean that the absolute value of x minus 4 is less than 0.01. And that matches up exactly with the type of statement that involves delta. The absolute value of x minus 4 is less than delta. Well, the absolute value of x minus 4 is less than 0.01. So let me write that in here. X minus 4 less than delta. So delta has to be this 0.01 right there. And we found the delta for this. We didn't even have to use a graph.